Hello and welcome. Good afternoon. So my name is Jim Pascoe. Today I'm going to be talking to you about how to master C++. And what I'm going to do basically is try and give you some practical tips for improving C++ knowledge. So sort of things that I've picked up over 20 years of learning C++ and trying to stay up to date with the latest standards and so forth. And I just wanted to, share those with you, so hopefully there's a few nuggets in there that you can, sort of incorporate into your own studies and your own workflows. If you want to follow along from the comfort of your own laptop, this is the URL at the bottom here for the talk. It's online, so it might be a bit easier from the back, perhaps, if you've got a device to see things. And also, I'm the ACCU Bristol and Bath Meetup Coordinator. So if you find it very easy to come here, in particular, we meet about once every 6 weeks, and we do, tech talks, lightning talks, social events, lots of, and it's a very nice group. So entirely, recommend that you come and find me afterwards, and I'll put you on the list for the event announcements. So why this talk? Okay, so like I said, what I'd like to do really is sort of present a mental framework that I sort of use for learning and sort of staying up to date with C++. So I think we can all agree it's a very big language. It's very complex. I mean, learning C++ is fun. It's a challenge to stay on top of it. It's a good thing for me because it's kind of like something that I'm very interested in that keeps changing, keeps evolving, so it keeps me interested. But as I said, it's complex and it's continually evolving. So how do we, sort of stay on top of this? How do we, sort of keep up to date? In particular, there's lots of different styles, paradigms, and idioms. So Victor's talk was a perfect intro to what I'm going to talk about in a minute. And, if you go about it in the right way, it's a very fun and rewarding language, but only if you sort of approach it correctly. So like I said, my goal this afternoon really is to share some insights and to tell you a bit about, kind of how I sort of structure and framework my learning so that I can try and sort of keep the salient points in my head and then, sort of use that as a basis for my sort of professional work. Okay, so this is a bit like my brain, basically, after trying to keep up with some of the developments in C++ and put that on top of kind of modern life and how we all work and so forth. And there's a lot of ideas, a lot of, views, opinions, histories, things that overlap, and trying to sort of stay on top of this. It's quite difficult. It's quite a challenge. And like I said, fitting that around your personal life and your career as well, it can be quite difficult. So what I'm going to talk to you a bit about this afternoon is mindset. And in particular, C++, it doesn't, in my view, it doesn't really have kind of one mindset. There isn't sort of one mindset for C++. There's actually lots. And, mindset as a term, it's a way of thinking. And as I say, there's lots of sort of facets and faces to C++. And they all require you to think in different ways, so different mindsets. So we start off with the imperative. And the imperative programming, I mean, this is how we all think. And, this is probably our first introduction to programming was imperative programming. But then, as Victor just pointed out, functional programming. That's a totally different way of thinking, really. Performance, how do we think about performance? Concurrency, that's also a very different way of thinking. Testing, well, you need to think differently in order to be able to do good testing. Object-oriented, the list kind of goes on and on. So what I tend to do is sort of focus on each and then try and blend them together. And this kind of leads to sort of one form of C++ mastery. So let's start with the sort of the easy one, the imperative mindset. What does that mean? Well, we solve problems by basically expressing each step. So what we're doing is we're codifying knowledge into the computer that says how to solve a problem, step by step. Lots of advantages to that. It's very easy to read. It's quite easy to learn. It's also easy to sort of switch language. So this is why if you've gone from C++, you pick up Java. Okay, yes, the syntax is different, the libraries are different, but broadly speaking, the way of thinking is the same. So you can quickly get up to speed and you can become quickly effective. So what I tend to do is sort of focus on the basics, and continually reinforce them. So when I'm trying to sort of develop myself in a kind of an imperative sense, I'm focusing on the basics, and there's been some good developments in this recently. So I don't know if anybody's noticed, but Bjorn Strustrup has put out a third edition of a tour of C++. So that was just before Christmas. So that's been updated to C++ 20. It's got some look-aheads in it to C++23. It's a very slim book. I'd highly recommend that. It's a very good one. You can get a lot out of that. C++ core guidelines. Who, just by way of a show of hands, uses the sort of the core guidelines in their work at all? There's a few people, kind of. They are definitely worth looking at and becoming familiar with. So, sort of on a day-to-day basis, sort of have kind of one eye on the core guidelines as you're doing things. That can really help you sort of develop, kind of your sort of imperative programming. The other thing I think it's really worth doing is to sort of understand the history of C++ a little bit. So there was a fantastic article that Bjorn wrote last year called Thriving in a Crowded and Changing World, where basically he sort of recounted the history of C++ from about 2006 to 2020. So has anybody come across this? Has anybody read this? It's in Community France. Fran has read it. Nobody else. Totally recommend going and looking that up. Again, it's in Communications of the ACM, but if you just Google Thriving in a Crowded and Changing World, it's brilliant. It's quite a big piece of work. It's like 90 pages. I have no idea how Bjorn Strustrup is so productive and prolific, basically. But he goes into kind of all of the decision-making around the sort of some of the basic features and the things, that go into C++. So is that a question? No, sorry, just stretching your hand, sorry. Totally recommend that. I mean, like I said, because understanding some of the history behind some of the decision-making that's gone into C++ really helps understanding why things are the way they are, and clarifies learning. Okay, right. The other sort of point I kind of point out with imperative code is when you're writing your code, imperative style code, optimize it for readability. I mean, this comes back to literally what Victor just said, but sort of we spend most of our time sort of looking, reading code, reading log files, this sort of thing. Invest your effort into making your code readable. So functional mindset. Well, again, so Victor's talked, perfect example of this, because if we just saw, kind of monads and this sort of, this style of coding on the screen, did it look like imperative code? Not really. I mean, and let's, so question, who in their first kind of meeting of functional programming started off trying to solve the exercises in kind of like week 3 of university by writing if-then-else statements and trying to implement for loops? Did anybody do that? Yeah, absolutely. I think, and that's basically your kind of mind's natural response to a new problem is that it's trying to apply its current way of thinking. So, right. So what's the difference? Okay, so functional mindset, it's more about evaluating expressions rather than statements. With the imperative mindset, what we're doing is we're evaluating statements, and as I say, we're telling the computer step by step how to solve our problem. Expressions consist of functions, okay, hence sort of functional. And basically this whole thing is a declarative style of programming. So the programmer is stating what needs to be done, and then the language by kind of magic determines how. So the way I sort of think about functional programming is I think about it in terms of states. So very often you've got a piece of data in sort of state A, and you want it to get to state D, but there's no direct path from A to D, but there is a path from A to B, B to C, and C to D. So that's kind of, that's, more of the sort of the mindset, sort of that I tend to sort of think about in terms of kind of functional languages. Stud ranges, it's very functional. If you want to see this in sort of real, kind of real everyday use, have a look at stud ranges. We'll have a look at some of that in a minute. And the other thing I'm going to say as well is that if you want to sort of a really good reference and a really good book to learn how to do functional programming in C++, have a look at Ivan's book. This is brilliant. This is a really good book. I mean, Victor's nodding, and yeah, I mean, I totally recommend. I actually, I actually took this on holiday with me last year. Which, I'm not sure my wife would, was particularly, I don't think she quite understood. But it's... I did the same. You did the same, yeah. But it's a really nice piece of kind of educational entertainment, if you like, sort of sitting in coffee shops and with a laptop and going through some, some material. This is a great book to do that from. So I totally recommend that one. Here's an example of what I would consider to be something that's sort of functional. So we can see that on line 7, if we zoom in on that, we've got a vector, numbers 1, 2, 3, 4, 5, 6. What we actually want to do is, or what the programmer is intending to express is to say, well, actually what I want to do is have these numbers descending, so sorted descending, and I'd like to get rid of the, the two biggest. So I've deliberately worded that in a way that's different from the operations on the screen. But you can see this kind of chaining together. So like I said, on the left-hand side where we've got vec, so we're in, if you like, state A. We know we want to get to state B, which is, as I said, we want to basically reverse the order of the array and drop the first two. And this is the sequence of operations that we can go through to do that. So it's kind of like going from a state, that we know to an intermediate state, another intermediate state, and then we're at our goal. What's it going to print? Can anybody tell me? Anybody want to say? So who said 4? 4, 4, 4? Yeah, brilliant. I should have brought prizes. I almost brought prizes. I want to give credit to Hannes Halswell for the example. And also, by the way, if you click the link, so Hannes, this blue bit, if you click the link, Hannes has got a very good article on ranges. If you want to, sort of do some work on ranges and you're looking for a sort of a nice tutorial, again, nice piece of educational entertainment. Okay, performance mindset. So this is getting a bit trickier. Okay, so efficiency. So a couple of key distinctions. Don't do unnecessary work. Okay, so and by that I mean this is where all of that kind of cracking the coding interview, leak code, algo expert, all of that stuff comes in, because what this is saying is basically you want the most appropriate algorithm and you want the best fitting data structure. So by that, I mean you want the data structure that's going to give you the best, sort of caching performance and so forth. Performance is about doing the minimal amount of work as fast as possible. And then as a kind of rule of thumb, so put your hands up if ever you've been given a piece of code and been sort of tasked with just make it go faster. Has anybody done that? Yep, like everybody. So come on, and then it's like, Jim, we need to make this code go 10% faster by the end of the day. Off you go. Here's a piece of source code. So some rules of thumb. So you do this, so you tend to sort of build it, run it in perf. What would be the first thing you guys would look to try and optimize at a sort of hardware-y level? Anybody got any ideas? No, okay. Well, first thing really is memory hierarchy. So, what you want to make sure is that if your program is going off chip to go and retrieve memory, right, that's the, as a rule of thumb, that would be the first thing that I would be, looking to crunch back. So either prefetch data or look at your data structures to make sure that your caching profiling is as optimal as possible. Then look at things like branch predictions and misses. Again, that can cause processors to, empty, entire I caches and so forth. So look at, trying to, you have some new attributes in C++20, the likely and unlikely, which is quite useful for actually sort of being able to say, okay, this is, the most likely, branch that you're going to take in a for loop, for example, or something like that. And then, only then, right, if that's not enough, look at optimizing the operations in your pipeline, so in your CPU pipeline. But, whereas what I've seen before in the past is that people tend to sort of focus immediately on the pipeline operations, and, they've got, sort of tons and tons of decache misses, things like that. Okay. The other thing which I find very useful is to define performance in terms of KPIs and stats. So try and move away from kind of absolute numbers. So rather than saying like, okay, handover time in my industry is a very, very important performance indicator. Okay, so rather than saying, okay, handover time has increased by 2 milliseconds, actually you're much better off if you can say handover time has increased by 2 milliseconds, but for 98% of the time we're still within our KPI of 100 milliseconds. Is that good enough? And very often the answer will be yes. And measure performance from the outset. So performance is one of those things, it's very difficult actually to sort of retrofit performance into a piece of software. Same goes for sort of concurrency design and security. You can improve performance, that's fine, but fundamentally if it's not, in an ideal world, it needs to be thought about from the outset. Good reference on this. Who here has come across Agner Fogs? Yeah, few people. Okay, right, this is, so Agner Fogh is a Danish computer scientist. These are a work of genius. I think there should be like a little counter in my office that says, sort of days since last accessing Agner Fogg's optimization manual. These are very, very good, focused predominantly on sort of Intel architectures. If you've not come across them, I think the URL is agner.org/manuals. Yeah, really worth a read, yeah, highly recommend those. Okay, concurrency. All right, so again, different mindset, different way of thinking entirely. So, key distinction, right. Concurrency is about items that are in progress at the same time. So these can be threads, queues, whatever, work items that are in progress at the same time. The key thing to note is sort of with concurrency is that you have contention for an executor, okay? So you may have two queues of work items, one of which may be blocked because a process is called a blocking operation. That means that another process can run in the meantime. So rather than wait for the first process to become unblocked, you can harness that little window of latency and run something else. By contrast, parallelism means that items are processed literally at the same instant, so at the same clock cycle. So this would be like two threads running on two separate cores in a CPU. Very often, I think it was Arthur Dwyer, CPPCon 2020 who said this, very often parallelism implies some form of extra hardware. So either you've got sort of multiple cores, so running threads on multiple cores, or some form of instruction level parallelism, or something similar. Now, C++, it makes it really easy to add concurrency to applications. We've got really nice, useful primitives like std_jthread, std_async. Listening to Bryce this morning, you've got std_execute, which is coming. And really, really interesting, sort of good stuff. Key thing is, I would say, if you're doing anything with concurrency, design is quite important. I mean, think about what you're doing, sort of really before you're doing it. Again, I talked to Anthony Williams, who I think actually, who's here at this conference actually, and from my perspective, is like the master of concurrency. And I sort of have a running joke with Anthony. I say like, so if you found any sort of good ways of doing concurrency design that aren't just pencil and paper yet, Anthony, and he's like, no. He says it's the same thing. It's like, no, it's pencil and paper and thinking, basically. But design is very important with concurrency. What you're sort of aiming to do is to kind of eliminate bugs by design. So rather than sort of reacting to kind of things like race conditions in the field, if you're starting to bring concurrency into your program, think about how can I make sure that A cannot race with B, rather than thinking, well, I'll just add these primitives, pop this on a thread, pop that on a thread, it'll all go faster, maybe, and then we'll react to race conditions later. No, think about it, take a step back, right, and try and ensure that A cannot race with B by design. And that way, things that do, bugs that do escape, if they do, will be a lot easier to fix because fundamentally, they'll be, the design is right. So this is a great book. So Anthony updated it in 2019. Again, when I want a sort of a go-to reference for concurrency, I look at Concurrency in Action. Second edition is really, really good. That's entirely well worth a purchase. And yes, talk to Anthony. I mean, he's here and very smart. All right, question. This is a piece of code that I wrote as like a little example for some coroutines that I was working on. Which mindset has that been written in, do you think? Maybe it sort of looks a bit imperative. Is that right? Would everybody agree with that? Yeah, sort of. Okay. What's happened here? Yes, Felix?
Yeah, you spawn on a different thread some actions to be executed, and then that's it.
Spot on. Yes, absolutely. And what I've done here is I've actually changed mindset. So this is the thing, because I've been going through this in kind of an imperative sort of style. And then suddenly I've introduced some concurrency, okay? And, like I said, it's very easy because C++ makes it easy to do this, and that's a good thing. But it's very easy to, sort of sprinkle threads around and so forth, because it's making it faster. But like I said, if you do that, just sort of catch yourself and just think, okay, all right, hang on, are there any sort of race conditions or possible, sort of issues with doing this? Okay, debugging. So this is another mindset. So debugging starts when you design the code, or it does for me. So proactive design versus reacting to bugs in the field. Now, we had a situation at Blue Wireless where when I joined the company, we had a piece of software. It was very monolithic. It was written in C++. And we put it out into the world. And I mean, it worked up to some extent. But as I say, it was very monolithic. It had been written, sort of in a very tightly object-oriented style. And it went into the world, and there were bugs. And basically, everything that had to be done, every modification, every change, everything that had to be done came back to the software team. So it was like, and there was only about 3 of us at the time, it was like an inverted pyramid of issues that were sort of, kind of pressing down on us. So we actually took a step back, and we said, actually what we'll do is we'll re-implement this in a different way. So we'll have a Lua abstraction layer on the top, which other people can use and look at and read and reason about. And then we'll have some C++ underneath to do all of the kind of the performance aspects. And that worked much better because it meant that people in the field could solve their own problems, fix their own bugs, essentially. And it alleviated an awful lot of pressure on the C++ team. So what I'm saying is, think about debugging sort of up front. If you're tasked with creating a piece of software, can we do something in the design that's going to make our lives easier later? Predict and prepare for sort of common bug categories. So we knew that there were likely to be concurrency issues in our product, so we implemented a form of synchronized logging. So we did a heavy design phase, and then we did a form of synchronized logging, and that was very useful, and that helped us a lot. The other thing we thought is that there are going to be reliability issues. So one of the sort of key aspects of our product, Blue Wireless, is that radios that we create are designed to go on masts, and they're designed to be left there for 3 years without any human intervention, okay? Because they sit alongside railways, and railways are very difficult to access to do works and stuff. So if you've got a lot of these radios, they've got to be able to be put up once in the middle of the night, and then the engineer leaves it, it's working, and it's got to work for 3 years. So we knew if there were reliability issues, we had to jump on it and really understand them and get through those quick. So we implemented a form of crash dump retrieval. So if something did crash, then we'd get the information that we needed, and we were able to sort of respond to it very, very quickly. It's actually very useful because we had, there was about a subset of about 0.5% of nodes would just randomly crash after like 3 days. And then you reboot them and it's all fine. And then about 4 days later, they would crash. And then, so what do you do? And the only way to do it really is with this kind of technology, so crash dump retrieval. So yeah, as I say, debug performance problems in terms of KPIs. So like I said, if you can get away from kind of absolute numbers, I said, so the handover time example for us, that was a good one because handover time is very, sort of very pertinent in our industry. So actually being able to say, well, okay, the fact that this is fluctuated by 2 milliseconds, but we still meet all of our KPIs, so we're good. There's nothing to do here. Okay, so mastering C++. There are lots of mindsets, okay? Compile time, testing, hardware. If we thought about it, we could probably fill up 10 more slides, without any trouble whatsoever. What I like to do is think about them individually. So it's like a personal learning project. You can, sort of go, I'm going to do some compile time programming and stuff. Try and work out what are the key idioms and pitfalls so that in your mind, if you're doing compile time programming, what are the sort of key things you need to think about? And also, what are the things that can go wrong? And then recognize transitions between mindsets. So if you're moving from a concurrency mindset into an imperative mindset, it's probably fine. If you're going the other way, you should probably do some design. And then blend them together, and then you can master C++. Okay, so all done. Sorry, I think I'm probably running tight to time. So. Any questions? Any quick questions? Or we got any time, Felix? Or? Nope, we're good.